A concept that we'd like to look at in calculus is the difference quotient. The difference quotient gives us the slope between 2 points on a graph. So the formula we can use for a difference quotient is f of x plus h minus f of x divided by h. That's assuming our h value is not 0. So the 2 points on our graph are x plus h and x. So we have the change in y in the numerator and the change in the x value in the denominator. So let's look at an example of how we would calculate this. So we're going to look at f of x is equal to x squared plus 2x, and we're going to find this difference quotient for a specified value x equals 1, and again assuming h is not 0. So we're going to need to evaluate this formula, f of 1 plus h minus f of 1 all over h. So we need two pieces of information. We need f of 1 and f of 1 plus h. So we plug in 1 into our function f. We get 1 squared plus 2 times 1, which is 1 plus 2, which equals 3. It's a little trickier to find f of 1 plus h. We see here that we get 1 plus h all squared plus 2 times the quantity 1 plus h. So let's expand that out. 1 plus h squared gives us 1 plus 2h plus h squared. And then when I distribute the 2, I get a 2 plus 2h. Now combining the 2h here and the 2h here, I'm going to have h squared plus 4h plus 3, and I've just reordered this so the highest power of h is first. So now we're going to substitute these values into our difference formula, and we see that we end up with h squared plus 4h plus 3 from the f of 1 plus h, subtract 3 from f of 1, and then divide by h. So I see that this plus 3 and this minus 3 cancel, so I get h squared plus 4h over h. And I can then simplify this a bit further by factoring an h out of the top. So each term has an h, so I have h times the quantity h plus 4, and then cancel these two h's to get the value h plus 4. Now this is the difference quotient value only assuming that h is not equal to 0. So I see that at x equals 1, my difference quotient for any h value that I want will be, aside from h equals 0, will be h plus 4. As a second example, let's look at g of x equals x squared minus 3x. Again, looking at h not equal to 0, but this time, instead of giving a specified x value, why don't we do this as a general function? So in this problem, we need to have g of x, which is just the function itself, and g of x plus h, which we see as x plus h quantity squared minus 3x plus h. So again, I'm going to expand my squared piece and then distribute the minus 3 into my second piece. So I get x squared plus 2xh as my mixed term plus h squared, and then I'm subtracting 3x and subtracting 3h. Now this particular polynomial cannot be simplified any further, so I will leave it as is. I'm going to substitute both of these pieces of information into the general formula, which is g of x plus h minus g of x over h. So notice this is the same formula as we see up here at the top. Only difference is my function name has changed to a g. So this gives me x squared plus 2xh plus h squared minus 3x minus 3h, subtracting the whole quantity x squared minus 3x, and then dividing by h. So when I subtract x squared, the first x squared at the beginning and this minus x squared cancel. When I subtract minus 3x, it becomes a plus 3x, and it cancels with this minus 3x. So I can simplify my numerator down to this 2x plus h term, this h squared term, and this minus 3h term, which I have written here. And just like before, I see that there's an h in each term, so I'm going to factor that out. So here's my h in each term of the numerator, and it is multiplied by the quantity 2x plus h minus 3. This h in the denominator and the h in the numerator can cancel, and I'm left with a function now from my difference quotient of 2x plus h minus 3. But remember, this is only true when h is not equal to 0. So, important note for all the difference quotient formulas that we do, we are making sure that our denominator is not equal to 0 because division by 0 is not a good thing.